So this unit is all about the sun and stars. So let's start learning about the sun and its structure. So first of all, we wanted you to think about what questions you have about the sun because we're hoping to answer many of those questions throughout this unit and the rest of the year. So one question that many people have is, how do astronomers know characteristics about the sun when we can't really get close enough to study it? Our sun is the only star whose surface we actually can study. Because it's a star that's close to Earth, we actually can study the surface of this particular star. In the fall of 2018, NASA actually launched what's called the Parker Solar Probe on a 7-year mission to study the sun. So you can see here, this is our Parker Solar Probe that NASA has launched, and it is traveling. And we'll see if we can watch a quick video about this.
NASA is counting down before a bold, historic mission to the sun. The Parker Solar Probe is scheduled to take off from Florida in just a few hours on a trip to learn the secrets of our star 93 million miles away. Here's Omar Villafranca.
The spacecraft, about the size of a compact car, will reach inside the sun's blistering atmosphere and come within 4 million miles of the surface. Project scientist Nikki Fox says 4 million miles may sound far away, but
if you put the Earth and the Sun in the end zones of a football field, Parker Solar Probe would be on the 4-yard line, and so that's very close.
Scientists hope the close-up look will reveal some of the sun's deepest mysteries, like the inner workings of the solar winds and why the corona, the sun's hazy outer atmosphere, is 300 times hotter than its surface.
Kind of breaks the laws of physics. You walk away from a campfire, you get cold, not hot.
The answers could help protect communication satellites, power grids, and even GPS navigation. The spacecraft won't melt because it's outfitted with this. A state-of-the-art 4.5-inch thick carbon heat shield that acts as a big umbrella between the sun and the probe's instruments.
How effective is this?
So on the front side, we get about 2,500 degrees Fahrenheit. And then when we get back to the spacecraft, we're about 85 degrees Fahrenheit.
The probe will become the fastest man-made machine ever built, reaching speeds of 430,000 miles per hour. That's fast enough to travel from New York City to Tokyo, Japan, in less than a minute. What also makes this launch special is who will be watching.
Dr. Gene Parker, this is...
Honor to meet you, sir.
Astrophysicist Gene Parker first proposed the existence of solar winds 60 years ago. Now, at 91, he's the first living person to have a mission named after him.
There is no return mission for the Parker Solar Probe. It will eventually run out of fuel, and unable to turn to protect itself, all but the heat shield will slowly disintegrate and turn into solar dust. Omar Villafranca, CBS News, Cape Canaveral, Florida.
So as you can see, we are actually studying the sun right now. So let's talk a little bit more about some of our parts of the sun, and we're going to really break it down into the interior layers and the exterior layers. And so again, how do astronomers know about the interior of the sun, that inner part, when they can't even see inside of it? Well, we use mathematical models to make inferences. We actually get information from studying sunquakes. So just like earthquakes, helping us figure out the interior structure of the Earth, even though we can't go in there. Sunquakes help us infer about the sun's structure also. And so when we talk about inferring, we mean that we are drawing conclusions based on data and observations, just like, we can infer that if we see smoke, there is a fire. Okay. So let's talk about those different layers. Again, the sun is divided into two large groups, the inner and the outer layers. So let's talk about the inner first. The inner layers include the core, the radiation zone, sometimes called the radiative zone, and the convection zone, or sometimes called the convective zone. The layers of the sun that are on the outside, those outer layers, are considered the sun's atmosphere. And so this includes the photosphere, the chromosphere, and the corona. And again, here you can kind of see those inner layers. So let's talk about those first. The core is where nuclear fusion occurs. And we'll talk more about this coming up later on. But this is where really we have our fuel and the reactions that fuel the sun. So remember we talked about nuclear energy. This is where that nuclear energy is really being produced. This is a quarter of the diameter of the whole entire sun. So it's pretty big. The radiation zone comes next, and the radiation zone is a region of highly compressed gas that surrounds the core. Energy passes through this layer by radiation, so the transfer of energy by waves. And energy can actually take 100,000 years to pass through this layer. That's pretty surprising. The convection zone comes next. This is the outer layer of the sun's interior, or the outermost layer of the sun's interior, and it contains convection currents. So we have hot gases rising upward, then the gases cool, and the cooler gases then will sink back downward where they can heat up again. And so we get this circular looping motion called a convection current. Next, we can think about the sun's atmosphere, or those outer layers. So we have the photosphere first. This is the innermost layer of all of those atmospheric layers. It is the brightest. It is considered the surface of the sun, even though it's not really solid, but we can't see through it. It's about 500 kilometers thick. It is bubbly in appearance because we get the tops of those convection currents, kind of those loops, looping into the photosphere from the convection zone. Next, the middle layer of the atmosphere is the chromosphere. This is actually hotter than the photosphere, but it's only visible when the brighter photosphere is blocked, like during a solar eclipse. So it tends to be a harder thing sometimes to study. The black dot there that you can see under the D is actually Mercury. So you can see just how big the sun is compared to Mercury. And then you can see in the lower right there, we have a picture of the chromosphere as seen through a special filter. And this is really where we get the color from the sun. Next, we have the corona. This is the outer layer, or the hottest layer of the atmosphere. It's only visible when the photosphere is blocked. And this is the origin of the solar wind. So the solar wind is a stream of electrically charged particles that can stream out from the sun. Here you can see a little summary of most of what we've talked about so far. So on the left, we have the core. Again, the core is the center of the sun, just like we name the core of an apple, the center of the apple. And again, this is where all the sun's energy comes from. The radiative zone comes next. This is around the core, and it produces gamma rays and X-rays that move the core's heat energy out towards the surface. The convective zone is next. The convection is happening when the heat rises and cooler gases, gas, liquid, or plasma sinks. The convective zone is made entirely of boiling plasma and sending heat up to the sun's surface. The photosphere, well, photo means light. So the photosphere is like a surface of light that covers the sun. The chromosphere comes next. The layer of the sun's outer atmosphere. The chromosphere is reddish in its glow. So again, chromo means color and sphere means ball. So it's a ball of color around the surface that can be seen during an eclipse. And so they've given in both of these last two a few ways in this picture that they remember these different things. The corona comes next, and corona actually means crown in Latin. So this outermost layer of the sun's atmosphere can be seen during an eclipse like a crown surrounding the sun. And then we're going to be talking about sunspots and solar flares. So the sun does sometimes get spots on the surface that are darker and cooler. And then the sun is so active that sometimes the energy just bursts out of it like a flare. And so we'll be talking more about these coming up soon. So one more thing to think about then is, again, why do we find it so important to learn about the sun? So we can take a second and watch another short video clip about that.
Is about to go where